In this concept video, we're going to be discussing critical points. A critical point is kind of where the interesting stuff is happening with a graph. If you want to think about it like that, it's any extrema, which is just a maximum or a minimum, or a point of inflection. We'll discuss extrema, maxes and mins here, so let's talk about a point of inflection right on the right-hand side. One interesting way to look at a point of inflection is if we take a look at the slopes of the lines that are tangent to the graph. So if I were to draw a dot here and draw a line that's tangent to that graph, meaning touching in one spot only, it would kind of look like this. Notice from left to right that the graph is increasing and also the slope of the tangent line is positive. As we approach this area right here, the slope of the tangent line begins to lower or lessen. It's still positive, but the slope is not as high as this point. So the graph is not increasing at the same rate that it was over here. There's a very interesting point right here where it appears if we were to try to draw a line that's tangent to the graph, hitting it at only one spot, the slope of the line would be 0. Here, as we continue up, the slope of the line continues to be positive. So for a point of inflection, we're going to be increasing to increasing, or it could be decreasing to decreasing, but we won't be changing the fact that the function is increasing or decreasing. And the point of inflection is this point right here, where the slope of the line that's tangent to this curve is 0. Also, this function will exhibit symmetry about that point. The entire function doesn't have to exhibit symmetry around that point, but oftentimes right here, that function will exhibit symmetry around this point. Let's talk about a maximum or a minimum. This is a little bit different than a point of inflection. Notice with a point of inflection, we were going from increasing to increasing, and the slopes of all the tangent lines were positive, and exactly when it was 0, that was the point of inflection, but they continued to be positive. For maximums and minimums, we're going to go from increasing to decreasing, or decreasing to increasing. So we could actually write that down. For a maximum, we're going to go from increasing, and we're going to have a change to decreasing. For a minimum, we're going to go from decreasing to increasing. Remember, we always go left to right when we say words like increasing, decreasing, or constant. So let's take a look at the first most interesting spot right here. And the first most interesting spot, this graph climbs, and then maybe right here at this point, the graph begins to descend. So we go from increasing to decreasing. Also notice this is like the top of a hill or a mountain. And it's a high point if you want to think about the high point, the value of y is high in terms of the function. So we're going from increasing to decreasing. We know this is a maximum. Then the graph descends and then begins to increase here. The exact point where that turns, and sometimes these are called, the maxes and mins are called turning points, is right here. So the graph goes from decreasing to increasing. This is a minimum. The graph increases, then begins to decrease again, and so this is going to be a maximum. There are two words that we need to write down though when we describe maxes or mins, and you'll see this differently given a different textbook or which textbook you're looking at or what you're looking at online. So I'll give you both. One way to describe this is absolute and relative. Some people will use the words global for absolute, and for relative they'll use the word local. They mean the same thing. Now absolute is the highest the graph goes, and I'm going to run out of room here. So this is the highest or lowest the graph ever goes. For this one, the relative or the local, it's just well, it's just the opposite of this. So it's a minimum or a maximum, but the graph at some other point is higher or lower depending on which one you're talking about. So let's go ahead and let's figure out these points right here, maximums and this minimum right here, these two maximums and this minimum. We'll figure out which one they are, either absolute or relative. If we look at this maximum right here, this y value will never be reached by another point or above that point. Notice how the graph, the y values here are lower. They reach a maximum. The y values are all lower than this maximum right here. So we would call this maximum an absolute maximum. This maximum, on the other hand, its y value is here. And you'll notice that for all of these points right here, they all have y values that are bigger than this maximum. So this is only a maximum relative to this area of the graph or to this local area, which is why it's called a relative or a local maximum. So we could write relative here. In this class we're going to be using absolute and relative. If you understand it as being global and local, maybe you had that in a different class or you're looking up something online or in a different textbook, that's fine. But we need to understand absolute and relative also. Those are words that you want to know. Let's look at this minimum right here. The y value is right here. We need to ask ourselves, is this the lowest the graph ever goes? If it is, then it's an absolute. If the graph at any other point has a y value lower than this minimum, then it's only going to be a relative. If you look at this section of the graph over here or this section, any point on this side or this side will have a y value that's lower than this minimum. Therefore, this is only a relative minimum. The graph at some other point has a lower minimum value than this local area right here, or this area relative to the rest of the graph.